Okay. Question 1. I think this was from a 2018, 2019 paper, so it was a good 4 or 5 years ago, and that's why I'm saying I haven't seen it since then, but guarantee this might be the year it comes up, so good to practice. Question 1 is saying, in the diagram below, the graph of f of x is equal to ax squared is drawn in the interval x less than equal to 0. The graph of f to the negative 1 is also drawn. P, negative 612 is a point on f, sorry, and I've forgotten, and R is a point on f to the negative 1. So that's our information. Now remember, I'm always saying to you, before you get to the questions, assess what information you have. So we've been given a parabola, f of x, which is this graph over here, for a specific interval, and that specific interval is x less than equal to 0. We can see that it's for all the x values that are negative. And we've been given the inverse function. Now, we don't know anything about the equation of the inverse function, but we know it's the inverse of f because of the notation that we're working with. I hate that line. Let's try that again. Because of the notation that we're working with. So that to the power negative 1 or negative 1 is telling me it's an inverse. That's good to know because I haven't been given an equation. I'm probably going to be asked at some point to find the equation of the inverse. Point P is just a random point on F. We can see that there. It's just random little point. Point R, also random little point on the inverse. That's the information we have. So the first question is asking me, is the inverse a function? Motivate your answer. So what do you guys think? Yes, it is. No, it isn't. You can give me a thumbs up, or you can just say yes or no in the chat. If you want to go a step further and give me a reason why, awesome. But is the inverse a function? Josh is on it. Nice. Okay, so Josh is 100% correct. Yes, it is a function. It passes our vertical line test. Now, when you are giving your reason, try and relate it back to that definition of the function that we spoke about, the fact that for one input, we get one output. If it wasn't a function for one input, we could get multiple outputs. So we always try and say for every x value, there is only one y value. Right? It's like I said, try relate it back to the relationship between x and y in our definition of a function. But Josh is 100% correct in the assessment of the fact that it passes the vertical line test. If you put your ruler on the page and you move it anywhere, it only cuts it once. So absolutely. Right, question 1.2 is saying, if R is the reflection of P in the line y equals x, write down the coordinates of R. Now again, let's not panic. Let's assess what information we have. This equation y equals x. This should be ringing a bell somewhere in your head because this is the line we reflect over when we're looking at the inverse. We also know that it has a rule that says if we've got coordinates x, y, to find the inverse or to find the mirror image, we just swap the coordinates. That's all we need to do here. So we know that the original coordinates of P was -6, -12. R is now a reflection over this line, so it's the inverse. So all we need to do here is swap the coordinates. -12, -6. That's it. So don't become flustered by the questions. Read it carefully. What information do you have? How does it help you get to the answer that you want? Question 1.3 is asking us to calculate the value of A. Now, A is coming from our f of x equation. F of x is equal to ax squared. Now, if you look at that purple graph, that is the parabola. It's obviously only a portion of the parabola, x less than equal to 0, because we know that the inverse of a whole or a complete parabola is not a function, so we have to restrict the domain. Because it's a sad parabola, hopefully we remember that A should be negative. So when you now go and solve for A, you should get a negative value. So you can tell me how we are going to find this value of A. What am I going to do? And again, you're welcome to unmute yourself, or you can just pop it in the chat. How are we going to find A? What do we think? Again, think about what information you have and how you can use it. You know grade 12s. Everyone's having slower Monday today. Okay, Josh has said sub in the point P. Exactly. Guys, P is on my graph. Oh, and Bongi and Kosi, thank you. I see your message too. Don't know how I skipped that. I do apologize. Substitute point P into f of x. P is on the graph. Any coordinate on the graph has to follow the rule of the graph. And so that's literally all we do. We're going to take P, which was -6, -12, and we're going to sub it in. So -6 is x, -12 is y, minus 12 is equal to a times -6 squared. -6 squared gives us 36a. Divide both sides by 36, we get -1/3 as our a value. Now, once you have your a value, obviously that means you've got your equation for f of x. And even though that wasn't what the question was asking, I've said this before, I like to just write it down in case it's going to be useful to me. I also have yet to find the inverse equation. So I'm going to need that equation at some point. For that, 1.4, write down the equation of f to the -1 in the form of y equals. So this is now asking me for the equation of my inverse function. So I'm going to give you guys 2 minutes. I want the equation of f to the -1. Just worked out what a is. That's going to help us. Let's find our inverse. Like I said, I'm going to give you like 2 minutes, 3 minutes, and then we'll have a look. You're also welcome to put your answers on the chat so that people can see if they're on the right track. Ooh, excuse me. And you're also welcome to put any questions on the chat if you have. Remember, the inverse of a problem will have a square root. So make sure you've got a square root in there somewhere. Okay, guys, let's have a look. So like I say, you should have a square root in your answer because it is going to be the inverse of your parabola. But let's see what we've got. Sorry, just was typing. Okay, so we know that the original f of x equation was what we just worked out. Now, personally, I like to write this now as negative x squared over 3. It helps me when I do the inverse. You don't have to. For me, it's just useful. If you write it as negative a third x squared, that's fine. So remember, first step is you swap your variables. X is equal to negative y squared over 3. I now see that I need to multiply by 3 on both sides to get rid of my fraction. Give me 3x is equal to negative y squared. Divide both sides by negative so that our y term is positive. And obviously we don't want the squared, so we're going to square root. Please remember that when you square root, you can have a positive or negative. So plus or minus square root of negative 3x is equal to y. We now need to decide whether it should be positive or negative. So we go back up to our graph and we have a look. Firstly, what I see is that the inverse function only exists for negative y. So if you have a look here, these are all negative y values. It's all below the x-axis. So that's the first thing I should bear in mind. The second thing I should bear in mind goes back to this original interval I was given. For the inverse function, it only exists where x is less than 0. Okay? So when we now go back down to our graph and we decide which is which, we said that the y value, and remember this expression represents y, must be negative. And so that automatically tells me that I am dealing with the negative square root of this function because, we'll get there in a second, come on. Because whatever the value of the square root is, it will then be multiplied by the negative 1 in front of the square root. And so that will give me the negative y value. I cannot find the square root of a negative number, and so that won't be possible, which is also why x must be less than equal to 0. If x was positive, let's say you substituted in a positive 2 there, you'd be finding the square root of negative 6. That's not possible. But if x was negative 2, you'd be finding the square root of positive 6, which is possible, and then timesing it by the negative 1 to get that negative y. And so we should always refer back to what our graph is, what we're looking at, what values would make it valid, what values would make it invalid, and we can go from there. All right, so I'm hoping this isn't going to be too small. Let's take a screenshot of question 1. If you have any questions, obviously, please ask. Otherwise, we're going to have a look at question 2. Alrighty, so if we have a look at question 2, this is now where we start to deal more with our exponentials and logs. So question 2 says, given the exponential function g of x is equal to a half the power x. That's all the information I have. So that's great. There's not really much I can take from that. But because I've got a whole bunch of questions based on a graph that I don't have an image of, my suggestion is when you do get something like this, just draw the graph. It doesn't have to be perfect. I'm going to do a very rough sketch of my graph. But if I know what I'm working with, it's going to help. Now, my base is a fraction. So this base is falling between 0 and 1, which means that my graph is decreasing. This graph decreases in this fashion. It's got an asymptote at y equals 0 on that x-axis. You could work out the y-intercept rather if you want, but we don't need anything more than that. All right. So the first question says, write down the range of g. Because I've now sketched my graph, that's actually really helpful because now I can see what it looks like. I can see what my range is. I can see that it only exists above my asymptote. And because my asymptote is y equals 0, my range is just y greater than 0. If you're a person who likes interval notation, y element of from 0 to positive infinity. Both of them round brackets because the asymptote is not included and we don't know where infinity ends, so we can't use a square bracket. So again, sketch a graph for yourself, know what you're working with. It really is super helpful. So 2.2 says determine the equation of g to the negative 1 in the form of. Now, automatically in our head, we should be thinking, cool, this is the inverse, and the inverse of an exponential is a log. So we now need to go back to our conversion rule to go from an exponential to a log. So I'm going to give you 60 seconds. I want the equation of my inverse function. Let's see what we get. Right, and remember, start by swapping your x and y, and then you can go and find your inverse. And remember, guys, inverse of an exponential is a log. So we should be getting a log graph. Let me give you another minute or so. Like what I'm seeing so far, guys? Good. Okay, I like what I'm seeing, guys. Well done. Let's have a look. So, like I say, inverse of an exponential is a log. We automatically know we should have that. Our graph, or rather our original graph, was y is equal to a half to the power x. Swap x and y, and then you can apply your rule to get the log. So y is equal to log of the base x. That's all we need to do. It asks us in the form y equals. You don't need to use the inverse notation. If you did, it would be g to the negative 1x is equal to log base a half x. But we were asked for y equals, so we leave it there. Right, 2.3 is g to the negative 1, a function. Justify your answer. If we were to just add the sketch to our little diagram we have going on, we're looking at the inverse. Let's hope I can draw this inverse relatively well. Yeah, it's not my best attempt in the world, but we're going to go with it. So there's the inverse. Again, sketch it, because now you can imagine for yourself, is the vertical line going to cut once, twice? Does it cut? You can imagine whether or not it's going to pass the vertical line test. Because of that, I can see it is going to pass my vertical line test. So yes, this is a function, because every x, there's only one y. And again, yes, it is passing the vertical line test, but our reasoning should relate back to the definition of the function that we know. Alrighty. So when we get to 2.4, yeah, we can do that. Just I want to make sure your screenshots aren't too teeny tiny. We've got the point M, A2 lies on the inverse. Okay, so if we have this inverse here, we've got this point M somewhere, A2. I've put it there because obviously it needs to be a 2 on the y-axis. Problem is I don't know what the x coordinate is. All I know is that it lands on or lies on, do you know why I said lands on? That's a weird statement. My inverse, which is y is equal to log base a half x. Great. Calculate the value of a. Okay, that's fine. I just sub it into the equation that I have. I've been given a coordinate, M, A2. This is an x, this is a y. Sub it into the graph. That's usually what we would do to find a missing value. So let's do it. 2 is equal to log base a half. X is now a. Now, unfortunately, we can't put this in our calculator, but we can convert it back to an exponential. So again, using your rule, you can convert back to an exponential and you are able to then determine what your value of a is. So this would now be your base, which is a half, to the power 2 is equal to a. And so a is equal to a quarter. Makes sense? It should be on the positive side. We're all good. It does mean that m is then a quarter to. We were only asked for the value of a, so we just leave it at that. Right, 2.4.2 says m prime. So this here is m prime. That little dash at the top means prime. Basically, what that means is it's an image. Some sort of transformation has happened to this coordinate to produce it in a new position or to put it in a new position. And we call that image m prime, a prime, whatever. That little apostrophe is prime. So m prime, the image of m lies on G. Write down the coordinates of m. Okay, we don't need to panic. The relationship between G and the inverse is exactly that. It's the inverse. The inverse tells me we have reflected over the line y equals x, which means that all we are doing with our coordinates is we are swapping them. And so all of that allows us to figure out what m prime would be. If m is at a quarter to, m prime would be where those coordinates have swapped to a quarter. So again, grade 12s, don't try overwhelm yourselves. Break down the question, start with the information you have, start with identifying how it's potentially useful to you, and then you can go from there. So don't overwhelm yourself with information, break it down, go step by step, and you will be fine. Right, 2.5 says if h of x is equal to g of x plus 3 plus 2, write down the coordinates of the image of m prime on h. Again, so much information. Let's just start with the first bit. Now, the first bit to which I'm referring is what transformation is happening here. So what we need to bear in mind is that x plus 3, anything that we're doing to x is going to affect my x coordinates, which means I'm probably shifting left or right. Now remember, x minus a value is a shift right, x plus a value is a shift left. So this transformation is a shift 3 units left. The second transformation that we were given was plus 2. If it's not in the bracket with the x, it's affecting the overall y value. And so this is a shift 2 units up. So all we want to do now is we want to take that m prime image, which was 2 1/4, because that's the one we're asking to refer back to. And we want to undergo, or we want to perform this transformation. So I'm currently sitting at x is 2. I need to go 3 units left. That's going to take me to -1. Now, guys, because this is the image of an image, we now use m double prime or prime prime. I was at 2. I'm moving 3 units left. I'm now at -1. I was at 1/4. I now need to move 2 units up. I'm now at 2 1/4, which is 9/4. If you want to write 2 1/4, that's obviously absolutely fine. I prefer improper fractions, but it doesn't matter either way. But that's it. So the tricky part of this question was understanding what the transformation was saying to you. Anything to do with x, shift left or right, and you then refer back to the expressions that we know from grade 11. Anything that's just a constant being added or subtracted, shift up or down. And we can then apply our transformation and we can get our answer. Right, so, oopsie. Let's take a screenshot of question 2. If anyone has any questions, obviously please ask. But like I said, over the past 4 or 5 years, it's been log graphs, very much log graphs. This is a really nice log graph question. Whether you agree with me or not is up to you. But we need to be comfortable with our log functions. Okay. So if we have a look at question 3, in this scenario, I've now been given a log graph. So in the last one, I was given an exponential and I had to work with that. Now I'm given a log graph and I'm going to have to work with this. So the graph of f of x equals log base 4x is drawn below. It's only graph. I don't need to figure out which is which. I've got that. The bit of information that I have on the graph that wasn't given in the information is the fact that b, which is a coordinate of k2, is on the graph of f. No surprise here. The first question is asking me to calculate the value of k. Now it's the same as what we said earlier. We've got an equation. We have a coordinate, x, y. Sub it in and solve. So y is equal to log base 4x. We're going to sub in our coordinate. So 2 is equal to log base 4k. We can't solve this on a calculator. We are going to have to convert to the exponential. So 4 to the power 2 is equal to k. And so k is equal to 16. That's it. All right. So once again, don't overthink. When you've been given a coordinate and you have an equation and you're looking for either the x or the y, sub it in and solve for what you're looking for. This does obviously mean that we know that b is at 16, 2. So that's that. All right, 3.2 says determine the values of x for which f of x is greater than or equal to -1, but less than or equal to 2. Again, let's not panic. First things first, f of x is a fancy way of saying y. So we're looking for all the y values between -1 and 2. We already know that y is equal to 2 at point B. We also then want where it is at -1. So there's 2, there's -1. We now want the x coordinates that correlate. We already know the x coordinate at 2. We know, we've just worked it out, that it's 16. We would now need to go and figure out if what this x value is at -1. Your -1. There we go. So all we need to do is substitute in, and we need to solve for x. Pretty much exactly what we've just done. So y is equal to log base 4x. We know that y is -1. So that's what we're going to substitute in, and we're solving for x. It's pretty much the same as what we just did, just with different values. So what we now have is 4 to the power -1 equals x. And so therefore x is equal to 1/4. So now I know that my coordinate, where y is equal to -1, has an x value of 1/4. This x value is 1/4. And now I've got my range. It's from 1/4 to 16. And so that's what I write. It's from 1/4 to 16. And that's that. So don't let inequalities frighten you, grade 12s. Right? Don't let inequalities frighten you. Look at what information you have. Understand what the inequality is actually saying, and you can then go from there. Right, 3.3 says write down the equation of f to the -1, the inverse of f in the form y equals. So we're just looking for an inverse equation. That's all we're looking for. We know that the original was y is equal to log base 4x. We now need to convert it to an exponential. Remember, of course, your exponential rule. So I'm going to give you a minute. I want you to tell me what the inverse equation is. And remember, guys, the first thing that you do, unless you can see it straight away, the first thing that you do is you swap x and y, and then you apply your rule. So now you can go and apply this rule. Nice. I'm assuming that's an exponent. I know that's not the easiest thing to type exponents. Okay, so what we have is y is equal to 4 to the power x. That's it. All right. 3.4 says, for which values of x will x times the inverse be less than 0? So again, let's not let this panic us. Firstly, let's decide where do we get negative values, because that's what less than 0 means. If we are multiplying, we can only get a negative by saying a positive times a negative or a negative times a positive. Those will give us values less than 0. So either our x needs to be positive and our inverse y values need to be negative, or the x values need to be negative and the inverse y values need to be positive. If I go to my graph and I just want to take all of this off, and I just very roughly sketch the inverse. The inverse would look something like that. Okay, so this would be f to the negative 1. If you have a look, this only exists where y is positive. So in terms of what we've just said, we're going to deal with the second scenario because y can only be positive. So now I need to establish where is x negative. Well, x is only negative to the left of my y-axis. So what that means is only from 0 to negative infinity am I going to get a product that is negative, because these x values are all negative, these y values are positive, positive times a negative is a negative. On the other side, all of these x values are positive, all of these y values are positive. Positive times a positive is a positive. It's not going to work. So it's only where x is less than 0 am I going to find a product that is negative. So again, don't let inequalities frighten you. Just read it really carefully and go from there. Okay, so let's do that. You can take a screenshot of question 3. I don't know how much we'll get through question 4, but we'll give it a try. So Bongi and Kosi, for me, I think it's easier to sketch the inverse. Obviously, if you can envision the inverse clearly for yourself, then it's fine. You don't need to. I do find it useful because it can be quite tricky to understand. And so I think having the visual of the graphs that you're working with is a lot easier to deal with. So my advice would be yes, but you don't have to. All right, guys, so let's have a look at question 4. This was actually the question from last year's final. So you get a good idea of what they had to deal with in the final last year. But let's have a see. Okay, so sketch below is the graph of f is equal to 2 to the power x minus 4. For the interval x is from negative 2 to 4, where negative 2 is included, 4 is excluded. And you can see that on the graph, but we'll chat about that now. A and B are respectively the y and x intercepts of f, but we can see them labeled on the graph, that's fine. So what I do just want to sort of point out here is here's our function and here's the interval. So we can see that 4 is excluded because it's an open dot, and we can see that negative 2 is included because it's a closed dot. It's only going up to those x values. It's not going past that. So that's just important to bear in mind as we move on. So 4.1 is asking us to write down the equation of the asymptote of f. So here's that asymptote. The asymptote, remember, is how much is shifted up or down. From my equation, I can see that y is equal to negative 4. Done. Literally nothing else that we need to do. 4.2 is saying determine the coordinates of b. Now, if you read the information or if you just look at the graph, b is your x-intercept. X-intercept is where y is equal to 0. So I'm going to give you 2 minutes. I want you to tell me what the coordinates of b is. Okay, good. I'm going to give you another minute. Oh, probably. Okay, so x-intercept, make y equals 0. You've now got an exponential equation. So 4 is equal to 2 to the power x. Make your bases the same, which therefore means that x is equal to 2. And so b is at 2, 0. Remember, it wanted the coordinates to try and write it as coordinates 2, 0. Right, 4.3 now says determine the equation of k, a straight line passing through a and b in the form of k of x equals. So this sort of goes back to Bongi and Kosi's question of do we have to sketch the graph? So in this case, it's not the inverse, but I would sketch the straight line. And the reason for that is you can see the properties of it. So my straight line has to go through a and b. So this is the straight line k. It's not my best straight line in the world, but we're just going to roll with it. So this is k. What you can now see is that k and f have the same y-intercept. And because they've got the same y-intercept, if you can work out the y-intercept of the exponential, you know the y-intercept of the straight line. And so that's the first thing I'm going to do, because remember k of x, because it's a straight line, is mx plus c. C is your y-intercept, m is your gradient. You also need 2 points in order to figure out the gradient if you're going to use the gradient formula. But the first thing I'm going to do is I'm going to work out the y-intercept of f. So f of x was 2 to the power x minus 4. Y-intercept means I'm going to make x equal to 0, so 2 to the power 0 minus 4, which is 1 minus 4, which is negative 3. So that means our a coordinate is at 0, negative 3. It also now means that in terms of my k equation, k of x is equal to mx minus 3. Oh, gross. So I've got the c value. To find m now, you can either go and use the gradient formula because you have those 2 coordinates, or you just sub in b and you solve for m. So if I sub in b, I would have 0 is equal to m times 2 minus 3. So therefore 3 is equal to 2m. Just going to carry on up here. So therefore m is equal to 3 over 2. So k of x is equal to 3 over 2x minus 3. Right, so you don't need to overcomplicate it, but again, look back to what information you have. How does it help you? We had the exponential. We could see that the y-intercepts were going to be the same. So that was where I could start with this question. Right, just because I think it's going to start getting a bit small. Let's take a screenshot there. Okay, so 4.4 says, calculate the vertical distance between k and f at x equals 1. So let's go to our graph to see this. Firstly, x equals 1 is going to be a very, very small little distance. So x equals 1 is probably about there because it's halfway between 0 and 2. So what they want is the distance between the graphs there. Now, vertical distance is that up, down. So we need to work out the y coordinate on both of those graphs to be able to determine vertical distance. But that's fine. We know the x value, and all we do is substitute in. So we're going to start, you can start wherever you want. If we start with a straight line, y, or rather, let's go k of x. And we're now looking for k where x is 1, is equal to 3 over 2 times 1 minus 3, which gives us negative 3 over 2, because 1.5 minus 3 is then negative 1.5. If we now substitute in for f, f of 1 is equal to 2 to the power 1 minus 4, 2 to the power 1. Sure, let's try that again. 2 to the power 1 is 2, minus 4 is equal to negative 2. So now we know that for k, the coordinates are 1, negative 1.5, and for f, 1, negative 2. Now, guys, remember, the trick is always to say your top y coordinate minus your bottom y coordinate. So the top y coordinate is on the straight line. So negative 3 over 2 minus the bottom y coordinate, which is negative 2. That becomes plus 2, so negative 1.5 plus 2, which means that that distance, we saw it was going to be very small, is actually just half a unit. That's it. So vertical distance, the trick or the little formula to remember is top y value minus your bottom y value. If you can remember that and you just go substitute and to find your y values, you're sorted. Successively big. So 4.5 says write down the equation of g if it is given that g of x is equal to f of x plus 4. Again, don't panic yourselves. Figure out what the transformation is. Nothing's happened to x, so there's no shift left or right, but we do have this constant, which means it's gone 4 units up. So f of x was originally this 2 to the power x minus 4, so it's already been shifted 4 units down. If I now shift this graph 4 units back up, all that's going to happen is that my asymptote now sits on the y-axis. And so this equation of g is just 2 to the power x. That's it. And again, you can go and substitute it in like I've done. You go and see what that transformation is, and you apply it to your graph. Right, 4.6 says write down the domain of the inverse. Okay, so g of x is equal to 2 to the power x. Now, it would be a bit of a mission to go and find the log. It's a bit of a mission to then go and figure out what the inverse would be. Remember the swap. Okay, so remember that the domain of inverse is equal to the range of the original. And so that's great. We don't have to do anything. We can literally go and work with what we have. We know we've got g of x. We know that that would just be a graph that looks like that. The range is y greater than 0, which means that the domain of your inverse is x greater than 0. That's it, because your inverse would now sit there. And so it's all of the positive x values. So this idea of swapping is so important when it comes to inverse functions. I can't stress that enough. It is so, so important. All right, the last question for this one is saying write down the equation of g to the negative 1 in the form of y equals. So we know what g is. It's just a nice, easy exponential. That means the inverse is going to be a log. So x is equal to 2 to the power y, which therefore means that g to the negative 1, or rather let's write it in formatted ones, y is equal to 2 to the power, no it's not, is equal to log base 2 x. So we know that the inverse has to be a log function. We can then go and work it out from there. Right, I can't actually remember where I said screenshot from, guys. I'm just going to go from 4.3. Right, so take your screenshots. If you have questions, let me know. But as you can, hopefully, as you can see, these questions are not hard. It's just about reading with understanding and making sure that we are actually doing what we're supposed to do and that we're applying our knowledge, i.e. domain of the inverse is the range of the original and vice versa. Making sure that we remember vertical distance is the top y minus the bottom y. All of those things that we know, but we just need to bear in mind. All right, guys, I know it's 5 minutes early, but we're not going to be able to get through a whole nother question.